I have one more of these types of problems that we can practice with. This one is asking the same type of question. Calculate the pH and the concentration of everything in solution in a 0.5 molar H2S solution. And we know that this is an acid because it's giving us Ka values, a Ka1 and a Ka2, which means we're going to have two dissociations. We're going to do these dissociations one at a time. So we're going to start with H2S. Always we're reacting it with water plus H2O. And because it's an acid, it's always making H3O plus. And to predict the other product, we have to ask ourselves, how did that H3O plus get formed? One of the hydrogens from the acid moved on over to the water. When that happened, H2S was left HS minus, and so that's our second product. Now we're going to make an ice table for this. The initial concentration of H2S is 0.5 molar, and initially we don't have any products. Minus X, plus X, plus X. In equilibrium, 0.5 minus X, and we're going to assume X is really small, so it's just 0.5. Also, X and X for our two products. This is Ka1 because it's the first hydrogen coming off, and it is H3O plus times HS minus over H2S. The Ka1 value is 9.5 times 10 to the minus 8. H3O plus and HS minus are both X, so that's X squared over 0.5. And we're going to solve for X. 9.5 times 10 to the minus 8 times 0.5, and take the square root of that. We're going to get 2.18 times 10 to the minus 4. And that's as much as we can do with the first step. So now we have to consider the second hydrogen coming off. So we are left, after the first hydrogen comes off, we're left with H2S. Now after the first hydrogen comes off, we're left with HS minus. Now HS minus is going to react, always plus H2O. We know that this is an acid because they're giving us Kas. Acids always produce H3O plus. And as far as the other product, we ask ourselves, where did the H3O plus come from? The hydrogen from HS minus moved itself over to the water molecule, and when that happened, HS minus turned into S2 minus. So there's our equation. Now we make an ice table, and the initial information in this ice table is going to come from the end, the equilibrium of our first ice table as much as possible. So for H2S, we look up to ice table number 1 and we see we ended with X, HS minus, and X is 2.18 times 10 to the minus 4. 2.18 times 10 to the minus 4. For H3O plus, we're going to look up to the first ice table. Do we have any H3O plus? We do, and it's X. And X is 2.18 times 10 to the negative 4. For S2 minus, we're going to look up to the first ice table. There is no S2 minus up there, which means that we haven't made any yet, so it's at 0. Change is going to be minus X plus X plus X. We're going to assume that X is really small. So at the end, HS minus is going to be 2.18 times 10 to the minus 4. And H3O plus is going to be 2.18 times 10 to the minus 4. And S2 minus is just going to be X. So we're going to make another Ka. This is going to be Ka2. And Ka2 is H3O plus times S2 minus over HS minus. Our value of Ka2 is 1 times 10 to the negative 19. H3O plus is 2.18 times 10 to the negative 4. S2 minus is X. HS minus is 2.18 times 10 to the negative 4. And look at those cancel out. So for the second ice table, X is 1 times 10 to the negative 19. We are now ready to calculate pH. pH is negative log of H3O plus, and we're going to take the H3O plus concentration from the second ice table, and that is negative log of 2.18 times 10 to the negative 4, which is 3.66. And for the concentrations of everything that we have H2S, we're not counting water, we have H3O plus and HS minus. H3O plus, HS minus. I'm looking at the second reaction, HS minus, which we've already written down. We don't count water. We have H3O plus, we've already written that down, and we have S2 minus. So we have 4 things. We're going to figure out all your concentrations. We're going to take data from the second ice table as much as possible. So H2S is not in our second ice table. It only shows up in the first ice table. So there we're going to get the concentration from the first ice table, 0.5 molar. H3O plus is in our second ice table, and there's its final concentration, 2.18 times 10 to the negative 4. HS minus is in the second ice table. There it is. And take the concentration from there, 2.18 times 10 to the negative 4. And last but not least, S2 minus in the second ice table as X. We're using the X value for the second ice table, 1 times 10 to the negative 19.